Well, hi, it's another day here. It's now July 9th. And so I think what happened yesterday is I made an interesting discovery, and then I headed out of my shop. Started doing other things in my house. I just never made it back in here again to carry on. So, an interesting discovery. Actually, it's kind of a hard to believe discovery. When I encounter things that are hard to believe, I don't believe them. So what's hard to believe? What's hard to believe is that resistor is supposed to be a 220 ohm resistor, but it measures 22. And I just don't believe it. So we're going to repeat the test. That resistor is integral to the feedback, the distortion controlling feedback system in the radio, or circuit. It's not really a system, it's more a circuit. And if it's not the correct value, the amount of feedback is going to be incorrect, and the result of that, well, I don't know exactly. I mean, you could get some kind of motorboating going on, I suppose, but maybe some other distortions which would normally be corrected are not corrected, or something like that's going on. I don't know. Let's just poke around on this resistor here. So I'm going to attempt to read it from the top. Ohms. It's not really terribly believable. 200 ohm scale. Of course, it's in the circuit, and the circuit could be, as much as I tried to figure it out, there we are, 6.4 ohms, 5 ohms. Well, in my experience, resistors don't go low like that. Funny looking soldering going on there. Let's take a closer look at the situation there. I'll just grab my camera from here. So let me put my finger on the resistor. I believe it's these two terminals right here. Oh, that's a bit of a circular pattern there, isn't it? What's up there? That's a circle. Nothing. And once that caught my eye, though, as being a little odd. This one here. Looks like they managed to solder the component wires, but didn't really get the solder to go down onto the trace properly. And it's funny that would make it through a factory, because it's pretty easy to spot. Now, is that a problem? Is that the problem? I mean, it's very unlikely that something like this is going to be the problem. Unless the radio made it on the market with this distortion in it. I mean, you would have to think that the distortion would be noticed in the factory. They would send it off to the repair bench at the end of the assembly line. Those guys would behave like me. They'd spend 3 days on this radio. Lots of bad looking soldering, but it's a camera image, and you just really can't see well with these cameras on this shiny metal stuff. There's all kinds of somewhat wonky soldering in here. Some of it's mine, of course. Well, we're not going to find anything looking at this, I don't think. The only option is to remove that resistor and from there test it. You'll just have to remove one leg. You have to pull one leg out, and then we can test it again. My guess is it'll read perfectly fine at that point. because I have no faith in this measurement I've made. There's no power on or anything. Good. Hey, what about the weather here? We haven't seen the sun for quite a few days now, really. Today looks like an all gray day. Big gray sky. Might be some sun tomorrow. The long range weather forecast on my forecasting app shows rain every day for the next 10 days. Boy, oh boy. I don't dare tell my cats that. Okay, I need something to hook the part. Here we are. So there's a hook on the end of it. Now they put these parts in so nicely and tight to the board. I have to hook the entire resistor. I can't hook the lead. And I'm really quite sure it's that terminal there and that one there. So I'm going to put some pressure on the pulling force on it here. Yeah, that's out. That was quick. One side anyway. Okay, lay it down, lay it down. And we should be able to make a better measurement here. Here. Okay, you're supposed to be 220. Do it like that. I don't think I can do this. Gotta do it from underneath a little bit. This is getting a little tricky. Put a clip lead on the resistor lead here. Oh, let's just make sure this clip lead's good before I add 500 ohms to this reading. That's good. And what is the truth? Where to go? Reveal the truth. The truth is it's 220 ohms. Truth is this can't be the cause of the problem. I gotta try to stick that guy back in there. Okay, so I'm gonna work on just sticking that resistor back. Well, I think from here I'm going to focus more on these two output transistors, which I've just gone on the assumption that they're working fine. They seem to be working fine from the testing I did, but I'm going to focus on them a little bit. But first, I just want to talk some more about this feedback circuit, which I certainly don't understand how this can work and what is really going on here. So I find this part of the diagram very confusing to look at. But if you notice, this a line that comes down to the let's call this the negative bus, or I'm not sure what to call this. We'll call it that. This might be positive. In fact, we'll go up here, follow it across, it dead ends. Go up further, follow it across, it dead ends. So this whole wire is going nowhere, doing nothing, unless you plug in some headphones. Now, if we follow this up through here, goes through the headphone switch, which is closed, back down to here. So it's just taking a long journey to get from here to here. So what we can do mentally is just wipe all this out. Just erase this from the diagram. This line disappears. All you have then is a very simple transformer secondary feeding the voice coil. This is closed, everything above is gone, and that wire doesn't exist. That leaves one wire coming out of here. This is the strange part to me. I would think you need two wires. Maybe. No, it's just looking at the radio. The speaker is screwed in to the plastic cabinet. back behind here, there's no connection between the metal frame of the speaker and anything around it. So I can't quite understand how this has an effect on anything unless it relies on some kind of reactivity through here. So it gets its ground connection somehow back through here. I don't know. I don't know how it works. So it's a real mystery to me. One wire back. That's one mystery. Next mystery is, for some reason, rather than bring this right to the, let's call it ground, they decided to stick a 5 ohm resistor in here and float this up a little bit. Why this is being done, I don't know. See, the bypass capacitor only operates to here. It doesn't actually go down to here. So what is this all about? I don't fully understand it. Puts me at a bit of a deficit. You can see this transistor is just going straight down to the ground wire here. They didn't stick a 5 ohmer in here. And I was thinking to myself, 5 ohms, well, this will be easy to find because how many can there be? And I looked in the radio and I started finding 1, 2, 3 of them. I look over here, yeah, there's actually 3. There's a 5 ohmer here, the one we're considering. There's 2 more, R2021. That's these 2 little guys. They're kind of in the same position again as this one, in the sense that they're lifting this a little bit off of this with 5 ohms. Now, 5 ohms in a vacuum tube radio, no, not happening. So, dealing with these tiny little resistors, I just want to imagine that they have no effect at all, but they must. They wouldn't put them in here. Otherwise, what exactly this is doing, I don't know. Is there a chance that these resistors have gone off? Well, there's always a chance. It's very unlikely. These guys, it's just nothing doing heavy duty in this radio. It's just fed with a couple of batteries. It's possible. Would that cause the kind of thing we're getting? I don't see how. If these things are really bad, then you would expect the output to be clipped, very viciously clipped output. You would see it on the scope, and that we didn't see anything like that on the scope. So what I'm going to do, I've reinstalled this resistor now. We're going to go and I'm just going to do some basic testing of these transistors while they're in the circuit with an ohm meter, and just because there's 2 of them, I can do comparative measurements. I compare the 2 of them against each other. That may, I don't know. Who knows? Let's go see. Let's go see. Okay. I've already tried this a little bit. There is an interesting result coming. So first of all, the 2 transistors are installed exactly the same. If you read the words on the top are the same. So lead for lead, same thing. So I'm going to pick on the first transistor here. It's hard for you to see this in the camera, but I'll try to describe what I'm doing. So, because you really want to watch the ohm meter, is really where the action is. So first thing is between legs. So I'm going to go, we'll call it on each transistor top, middle, bottom, because they're kind of laid out that way. So we'll do, and I got polarity issues here too. I've got this set here on my. That's a short circuit indication. Maybe we're going to hear that. So we're going to do top, middle, one way here. And the sound coming out of the speaker, right? Okay. Interesting. 700. That's a millivolt reading. Don't know why we're getting that, but that's okay. We'll go do exactly the same leads on the other transistor here. Maybe I wasn't doing the same leads last time. There we go. Okay, we're getting the same reading. So now we'll do the middle and bottom. Just polarity's kind of random here, right? Just comparative testing. Middle and bottom. Okay, get an unusual reading there of 97. It could be millivolts. go to the other one here, which is middle and bottom, middle and bottom. You get the same thing again. Okay. I mean, what are the chances that both transistors have gone defective in the same way? It's not very likely. So if these all look the same, I think we can claim these transistors are good. So I've done top, middle, middle. Now I got to do top, bottom, top, bottom. Again, a funny number, 666. Okay, 665. 666 sounds more interesting though. Here we go. Same number. There you are, 666. So, I mean, they're testing the same. I can reverse the leads now and repeat these tests. Oh, it looks like I've reversed the leads already. Uh-oh. Let's go back to the first one here. Now, you don't expect anything unusual to happen at this point. 130 measured there. Now we'll try the same thing on the other transistor. $130 coming, 150. Good enough. Middle bottom. $100. It's kind of odd again. 100. Polarity is not important. Could be I'm reading components outside of the transistor because it's in the circuit. So there's no variation in the readings between the two transistors, which suggests that transistors are the same and the circuits they're in are the same. It means these transformers, the input-output are the same. Everything's the same. Either it's bad in the same way on both circuits, or there's nothing wrong. And I would go for number 2. There's nothing wrong in here. That's not helpful to me, though. You know, the next step with these two transistors would be to remove them and test them outside of. Another way is to put my 3-lead tester on it and see what it does. And let's do that's another comparative test. Tricky getting these all on here. 1, 2, 3. Okay. What do you say? Now, it's in the circuit, so it might just come back and go. Oh, it's making sounds on the speaker. That's interesting. So it's decided it's 2 diodes in a row. What is it saying there? It's going to go off any minute. 1. Lead 1 would be on the base, potentially. Let's see. Lead 1. Well, I don't know where the base is in this transistor. Okay, so we're going to try to do the other one in exactly the same way. Okay, Mr. Instrument, speak your piece. Detects it the same way, lead 1 in the middle. Very similar numbers there. So why it doesn't say it's a transistor, why it says it's 2 diodes in a row, maybe because it's germanium? But again, these tests are just suggesting that everything is normal. Now I'm interested in this meter. Let's put it on a speaker here. Hear it. So my understanding is the way this meter works is it puts a series of test signals into the item under test. And voltages, not exactly sure. frequencies, I don't know. Let's stick it right on the speaker here and see what we hear, if anything. I doubt this would be loud, but maybe. Okay. It's pretty quiet. Well, it's just giving it as a coil with resistance, which is exactly what this is. I'll put this up near the speaker. You can hear what it actually did. Up near the microphone, rather. Here we go again. Just a bunch of clicking and stuff. So it's not, I thought some musical tones would come out or something more interesting than that, but no. Okay, still a bit of a mystery how this guy does his job, but once again, what a great instrument. I'm not trying to promote this particular one, but I think it's very popular. I think it is. So I certainly, every time I bring this out, all the other equipment in my shop shudders. Look at these guys. Oh my gosh, did you see that thing? Look at them all. They're all wide-eyed when I bring that other instrument out. Okay. Okay. Yeah, that was my hands. Well, I gotta stop and think, because I just don't know where to go from here at this point. I gotta come up with I need a theory. I really need a theory here. Some theory. Okay, new game. I'm going to try injecting signals into the radio, progress through the circuit, and listen to it as it comes out of the speaker, and see if that also can't help better localize where the problems are in here. Oh my gosh. Okay, so I have the sweep generator going, but I don't think it's sweeping. I think it's on a steady signal. Let's just touch the speaker and hear it. Make sure we can hear it. This might take a moment here. The radio's not on, so there it is. So that's the tone we're using. Okay, let me just turn it down level-wise here. Okay, apply power. Radio's off. Power on. Here we go. Wow, like once again, I get another radio where you can't turn it down to 0. Okay, tone. So it sounds distorted here, but I think where I'm injecting it may generate the distortion. It's right on the diode. Okay, so we'll go on the output of the volume control here. Whew. Sounds bad to me. Sounds like a roar comes through with it. Okay, now we'll move further up. We'll try the driver for the transformer that produces the inputs to the 2 speakers here. Let me reduce this. Okay. Wow. Boy, does that ever kill it. So the signal generator is a low impedance device. That could be why I'm telling it. I'm not sure. How come we didn't hear that? Let's give it more juice here. Signal juice. What's that sound like again? Let's put it right on the speaker here. So now, that sounds proper. I can't hear any harmonics in it. but when we're listening up here, certainly hear harmonics. So problem must be further this way. So I will now attempt to feed this signal into the two transistors here. That was a little unexpected. Could be those 5 ohm resistors are now affecting this. What I just did. I don't know. Why the hum? Why the hum there? Let's give it a little more signal strength. Does it sound the same, whatever it is? Yes. Trying to inject the signal into the primary of this guy here. What do you think? Does that sound distorted? Let's give it a little higher signal. That's not bad. Now, when I check this transistor here, okay, listen to that, and then listen to this. Does it sound much different? Let's look at it on the scope. Hear it? That was through the transistor. You know, it's around this transistor. That's the one I replaced. Okay, let's go back a little bit further back. We'll go to the next transistor back. You shoot the signal into the base. You probably don't need much signal to do it. Sounds buzzy, distorted to me. I got an idea here I'm going to try. Okay, so here's the idea. I've been relying on my hearing to recognize the when harmonics are present in the sound. It's not very quantitative, is it? So I'm going to put on the screen a frequency spectrum analyzer, piece of software. It's going to be analyzing what is coming through the microphones that you're listening to my voice with. It's not directly connected in any way to the radio. That should be good enough. Then we can visually look at the harmonics that are being generated as I move the input around on the radio. So first we'll look at the entire screen here and get familiar with it. So the interesting part to watch is down here. This is a frequency display. This one up here is a time-based display. So the frequency display here, you can read the frequencies down here. 100 hertz, 1000 hertz, 2000, 3000, all the way up to 20,000 hertz. You can see when I make an S, that's up in the 7,000 to 8,000 hertz range. Yeah. And if I do a low note, ooh, way down here, 100? I hit 100? Ooh. But there's harmonics running all the way up here. Now I'm going to put the tone first onto the speaker, and I don't want to hold it on. I'm going to clip it on the speaker. We're going to listen to the signal generator output driving the speaker with nothing else happening here. Just get it hooked up here. Okay, a little more volume. So again, on a lower display, we see this. You can see a little thing here. Watch this one. I'm going to raise the input level. This is right on the speaker, so I don't think I can actually kind of overdo it. Hear it? Watch this area and listen to the sound as more harmonics go into it. Let me turn down my microphone just a wee bit. Here we go. If you're good, you will have noticed that when the harmonics are present, the sine wave up here stops looking really beautiful and starts getting sharper at the bottom and a bit of a funny curve in it. So you can see harmonics in the frequency display, but way better to see them down here. Okay, so now I'm going to do the same where we're going to watch the tone as I move it in different locations on the radio. I'm going to change the screen here so we can watch the whole deal at once. Oops, we don't need the weather report here. Okay, now on the speaker, we'll just look once again. And you can see where the peak is. And you can see one like the next harmonic starting to show up. Okay, now we're going to inject the same signal. We're going to inject it into the primary of the transformer that feeds the two output transistors here. Okay, a little more. I mean, you can hear it, right? Look at all those harmonics. That's in the transformer. This is on the speaker. I'm seeing them all again. Hey, that was a little odd. I had this up a little high, volume-wise. Okay, we're going to go from here, right on the speaker. Sounds beautiful to hear. Yeah, so if I raise the primary frequency to the same level, you see the lots of harmonics. So that really suggests that there's a problem right in this guy, which I don't see how that can happen. Something wrong with the circuitry in here, aside from the transistors, which appear to be okay. What about this output transformer here? Hey, I didn't even have it on. What? Wait, we're caught in picking second. I didn't even have the thing switched on. That's maybe a reflection on me. Okay, let's turn it on and do these same things again. I'm blown away by all that. Okay, so transformer. That sounded nice now. Lots of harmonics though. Who's that? Who's here? Peanut. Is that you? He's gone silent. Back on again. It's a crazy day here. Yeah, that sounds full of harmonics. That doesn't. Although it's got the hum in it. That does. That sounds full of harmonics. That doesn't. So that's the input side of this transformer versus the output side. Feed it in the output side, tone sounds good, harmonics low. Feed it into the input side, doesn't sound good. Can that occur because of this guy himself? Or is it really reflective of a problem on the primary side circuitry? Brings us right back to this transistor. And when I'm feeding the signal in here, there's a circuit is hooked up to this guy. Maybe that circuit, and this transistor in particular, could be accidentally causing the harmonics that we're hearing. Do you agree, Peanut? Are you in on this? Out? You want to go in the garage? What do you think of that? Yeah, I like that idea. You want to go outside? Hey, pay attention. Do you want to go outside? Yeah, I don't know. I have to go play with my cat again. Give me some time to think about this stuff. Give my brain 20 seconds to process things here. Well, how a little transformer like this could distort the signal, I'm not sure. So what I've done is I've got the set is off. I've got the signal generator going onto the primary of this transformer right here, and then I've got the scope looking at the output of the transformer. So what you're looking at on the scope is the result of the signal coming out of the signal generator. If I turn it up a bit, I'll stop it here so we can get a better look at it. So sine waves don't get any better looking than that. There's zero distortion generated by the at least this side of the transformer. Let's just look at the other side of it. Exactly the same. Actually, it'll be inverted 180 degrees, which is the whole idea of this little transformer. Provide two inputs to the two transistors there. So where do we go next with this? Good question. Don't know. Okay, I just stopped the video and realized right away there is something I can do very simply. Turn the set on and listen to what comes out of the speaker under this arrangement. So the signal going in here is going to be a little high, and I'll just knock it way down. Knock it way down. We'll start with it very low. There we go. Okay, start putting the signal in here. So these are attenuation pads I'm removing. Where's the signal? It's interesting. It comes through with a pile of noise. So I just turned the volume down on the radio. So that sounds harmonically distorted to me. There's nothing on the scope there. Let's take a look at the harmonic situation here. Okay. So there's three. I can see three. Oh, many harmonics, and you can hear them quite clearly. So this could be because the input signal is being messed up by the fact that there's components connected, including a transistor. Where is certainty on this? If I turn the set off, like if I crank up the output, it sounds better. No, it doesn't. Okay, what it sounds like when the set is off doesn't mean anything at all. I am mighty stuck here on this little radio. Right back to the transistor that I fooled with before. So let's just think about this for a second here. When I feed a signal in on the output side of this transformer, which is really kind of directly into these transistors, the sound is pretty good. When I do on the primary side here, it doesn't sound so good. Harmonics are showing up. Yeah, there we are. That's the analysis. I gotta stop. I gotta stop and go away for a while on this. Man alive. Yeah. See you later.